This is definitely one of those classical story problems. So what you have is you've got the boat puttering along at 20 in still water, and then you've got different amounts of distance, right? That's a rate. Then you have different amounts of distances. Distance 1, oh, sorry about that, and distance 2 in the same time, right? T is the same, so T1 equals T2, right? And somehow you're supposed to be able to make sense of it. It's all in the distance, rate, time. In this problem, they ask the question of what, right? They ask a very direct question, so it's best to just let x equal the average speed of the stream. So now think about it, right? When you're going downstream, right, the speed of the stream is added to the speed of your engine, right? The speed of your stream is added to your speed of the engine. So that's your rate, right? Your rate downstream. The distance downstream is 47 kilometers. So your distance downstream divided by your rate downstream is the amount of time it took for you to go downstream. And of course, same thing upstream, right? If you imagine yourself going upstream from where you started, the water's going against you. So your rate down the river, right? Your river rate is subtracted from your engine's rate, right? Instead of adding, you're subtracting. If it's going 5 kilometers an hour flowing towards you, your engine is pushing the water at 20 kilometers an hour. Well, you're only going forward 15 kilometers an hour because you're pushing against it, like walking up a down escalator. So the rate of speed going downstream is 20 minus x. The distance going downstream, oh, that's 33 kilometers. So now we have the downstream time, right? The distance divided by the rate is time. And that distance over here, this distance, d1 divided by rate 1, is the downstream time. And T1 is equal to T2. So all we have to do is set these equal to each other. I will leave it as an exercise to the reader to go ahead and finish this up. The arithmetic is really not that bad, right? You start with the cross multiply, so you're already at a linear equation, you know, after one step. So it can't be too bad, right? And where's my x's? There's my x. And plus 660. I mean, you can almost see, right? The 660 is going to subtract from the 940. The 7x is going to add to the 33x. You think it's a coincidence that 7 and 3 make 10, right? It's going to end in 0. They're trying to make things easy for you, as they often do when you set it up correctly.